All right, so this is Dr. Sweeney, and I wanted to begin our exam 3 review with going off over hypothesis testing for proportions and using a critical value method. In particular, for this particular review video and all the review videos for this exam, I wanted to give you a sense of the kinds of questions that might show up. All right. Inside of this test, we're not going to be doing computation. It's all going to be theoretical. And so what we want to be able to do is we want to be able to utilize information in order for us to be able to run hypothesis tests and do confidence intervals. So for example, let's take a look at this question and let me show you how I might think about it in order to answer the particular question. Okay. So shortly after the Apollo 11 lunar landing on July 20th, 1969, a survey revealed that 28% of Americans do not believe it had happened. You have a theory that people nowadays are just as cynical and distrustful of government as they were back then. So you randomly sample 75 people and find that 25 of them do not believe that an Apollo 11 landing actually happened. Using technology, we found the test statistic for the test was z equals 1.029, and the critical values for the two-tailed significance test with significance level of 0.05 are negative 1.96 and 1.96. Test the claim that the percentage is the same as its 1969 value with a significance level of 0.05. Okay, so what I want to do here, I'm given all the information that I actually need. I don't need to do any computation here. What I need to understand is how the critical value method works, and then use that in order to do my main goal, which is to reject the null hypothesis or fail to reject. So we first want to remember, right, my goal is to reject or fail to reject the null. Okay, so it's going to be reject or fail to reject the null. Okay, now, given that that's going to be my goal, right, I need to know what my null hypothesis is. And so essentially that's going to be p equals 0.28. Notice it's a percentage, and that it's a percentage of Americans did not believe it had happened. Okay, so my h naught, my null hypothesis, is going to be p equals 0.28. Then I'm going to say, okay, well, what's my alternative? And this is one of those things that takes some practice, and it requires you to do some reading. But if you notice, you're going to test the claim that the percentage is the same as its 1969 value. That means my alternative, HA, is going to be P does not equal 0.28. Okay? Now, if you remember from our key terms work and from our work with setting up the distribution, this alternative hypothesis is going to tell you how many tails that we're going to work with. So I'm going to draw that distribution for us so that we can kind of get a sense of what that looks like. So here we are. Here's our distribution. Okay, we're going to have P in the middle, and that's P equals 0.28. That's my my null hypothesis. And then this is going to be two-tailed. All right, and if we remember, my significance level is going to be the size, right? Alpha is the size of these two regions, the critical regions. And in this case, it's split. Now, for this question, we don't actually need how big it is right now. All we need to know is what those critical values are. Okay, so the critical value right here, this one is going to be 1.96. That's a z-score. And the critical value over here is z equals negative 1.96. Okay, so those two values are going to be crucial for us understanding whether or not we reject or fail to reject the null hypothesis. So we got those two. We've got my distribution. I draw in my test statistics, or I think about them, right, where they are. And then I'm going to have z. Now, z is 1.029. So if you remember, the mean is z equals 0. And so 1.029 is basically halfway between here. So there's z equals 1.029. That's my test statistic. This one here is z alpha, and this is z alpha. Okay. Notice, right, that z is between the mean and the critical value. It's not outside of the of the critical value. So z is between the mean and the critical value, right? So consequently, we're going to fail to reject the null hypothesis. That's it. That's it. Okay? Since z, in this case, okay, and what we'd write is less than 1.96, we fail to reject the null hypothesis. So what we're going to need to visualize, okay, or write into your whiteboard, because you'll have that ability, is you're going to visualize, right, that you put in your critical value wherever it's at. So this is your your Z alpha, your critical value. So that allows you to draw in your critical region. If Z is in the critical region, right, okay, here's your test statistic. If Z, your test statistic, is in the critical region, you're going to reject. Since in this case, Z is not in the critical region, we're going to fail to reject. Okay? So let me kind of review what kind of information I used in order to do this. Right? It's just about putting together information and thinking about it from the perspective of our hypothesis test. So I'm going to look at this and I'm going to say, okay, well, first, I'm claiming, or there's a claim that 28% of Americans did not believe that the moon landing happened. So that's going to be my null hypothesis, p equals 0.28. Notice this is not sample data. My sample data is going to be this 25 and the 75. Okay? Parameter information here goes to become my null hypothesis. Okay? P equals 0.28. That's a crucial skill to be able to do in order to do well on this test. Then what I'm going to do is I've been given my critical values, negative 1.96 and 1.96. Okay? And I can draw those into my distribution. I put my mean, in this case p equals 0.28 at the center, and then I'm going to put in my critical values on either side. In this case, we have it on both sides because it's a two-tailed test. Okay? So then I'm going to take my test statistic and I'm going to imagine or write it in on where it is in the distribution. Okay? If my test statistic is in the critical region, then I'm going to reject. Since my test statistic is not in the critical region, I fail to reject. And that's it. So since Z is less than 1.96, we're going to fail to reject the null hypothesis. And then I'm going to write this, my conclusion, there is not sufficient evidence to reject the claim that 28% of people believe the moon landing did not happen.